Okay, part 284C3M1b7C8E13C9C6D3D. Line 22f1fa19c3m1b7c8e13c9c6d3d. Copper binuclear toroid blade, UFO 5G Wow Seti. So this video is the first keyword from the past video. So the last video has about 10 videos explaining each keyword and the formulas that go with it. And that's what this is all about. So this is the well alien radio signal. This particular one is doing the keyword research for a copper binuclear crystal structure and 7 beta-propeller found in the WOW data. And I had to divide up the data because there was too much. So January 14, 2013, today's the 16th. Keywords to Google from our previous video was line 22f1fa19c3m1b7c8e13c9c6d3d. Divalent binuclear copper crystal structures 5G Wow Seti. So the quotes are from WIKI. So we're going to look at intermonomeric surface. I didn't know what it meant. So it's a form of electron transfer. I couldn't actually find a definition. That was just some of the keywords that came up with the links. Okay. So cupredoxin is a blue copper protein function as a mobile electron carrier. So it's we have an electron transfer, then we have electron carrier, and it's a blue copper protein. Okay. Next was dinuclear electron having 2 nuclei, so that means there's 2 nuclei. 7-bladed beta-propeller domain. In structural biology, a beta-propeller is a type of all-V protein architecture, characterized by 4 to 8 blade-shaped beta sheets arranged toroidally around a central axis. Each sheet typically has 4 antiparallel B strands twisted, so oh my god, we've got the B strands and then we got twisted. The keyword twisted would have been the nanowires. Oh, I didn't even see this before. I've got another formula here. So that the first and fourth strands are almost perpendicular to each other. So this is the structure they want you to do. The M sign's active site is often found in the cleft formed in the center of the propeller by loops connecting the successive 4 sheet motifs. Merzen proposed a geometric model to describe the structural principles of the beta propeller. According to this model, the 7-bladed propeller was the most favored arrangement in geometric terms. So you see how it goes in a circle pattern and then it has a circle in the middle? This would be your core area. And this is showing how to create the rotation around it, I believe. That's what it is. Because it talks about the elshelby twist. It's got the twist and it's got the nanowires there. And I don't even have a formula written here. So, guess what? I'm going to have to go back to this and add formula later for the 7-blade propeller. I didn't understand what this propeller thing was, but obviously it's nanowires and elshelby twist. I'm going to go back over it again and add formula, and then we'll do that in another video. Actually, like I always do, right? Gotta add a note. And so we got the 7-blade propeller. Oops. And we got nanowires. And elshelby twist. And then it's got the actual structure listed there too. C notes. And this is January 16th, so I know which day I was filming it. Okay, so that's it there. So next, the ribbon diagram of the C-terminal WD-40 domain of TUP1, a transcripted co-depressor in yeast, which adopts a 7-bladed beta-propeller fold. Ribbon is colored from blue N-terminus to red C-terminus. Histidine and measles, Google and next video. So this particular, this is going to have several factors. First, it's talking about a structure that we can use for the core. But also, we're also looking at the components of a bendable metal. And when I say bendable metal, I mean it actually can bend and it can form into different shapes based on what it needs to, whatever shape it needs to do to the type of travel it's going to do. I know it sounds really crazy, and we see it in movies and stuff, like Transformers and stuff like that. But honestly, the stuff that's coming up in the data shows you how to do it. So obviously, that's what we're going to be making. Okay, thanks for watching.